All right, so these are the notes for graphing quadratic functions in standard form. All right, so the graph of a quadratic function is called a parabola, which is like a U shape. A parabola has three things. So it has a vertex, it has an axis of symmetry, or you may hear it say as line of symmetry, and it has X-Intercepts, which has several other names, and we'll go over those in a moment. So the blank of a parabola is the highest or lowest point on the graph. So that's going to be the vertex. Okay, and over here, so the vertex of a parabola is the highest, which would be a maximum, or lowest, which is a minimum. So highest or lowest point on the graph, and that's usually designated by the y value. So the y value of the vertex is going to be your maximum if it's the highest and minimum if it's the lowest. The blank is a vertical line that goes through the vertex. We refer to that as the axis of symmetry. But you may also see that as the line of symmetry. Sorry about that. So axis and line of symmetry, they usually use those interchangeably. The blank are where the function crosses or touches the x-axis. So that's going to be the x-intercepts. Okay, a couple other names we have for the x-intercepts is called the roots, the zeros, and the solutions. So those are four names. So x-intercepts, roots, zeros, and solutions are where the graph crosses or touches the x-axis. So over here, first thing we have is this vertical line that passes right here to this point. This is called the axis of symmetry, and I also refer to it as the AOS in short. And this is an equation. It's x equals a constant, okay? So that's how you would figure it out. So x equals a constant. So in this case, right here, I can see that it passes through -1, so x would equal -1. For this is going to be our x-intercepts, our roots, solutions, or zeros. So once again, this is where the graph crosses or touches the x-axis. So in this case, the way I would write the x-intercepts, this one appears to cross at 4, so 4, 0. And this one at -1, 2, 3, 4, 5, -6, 0. And usually we write these roots as x, 0 when we're writing our x-intercepts. The last thing we have here, this is the lowest point of the graph. This is called our vertex. And like we said before, if it's the lowest point, it's called a minimum. The highest point is called a maximum. So in this case, to get the value of the vertex, we got to find the coordinates. So x is -1, so it's going to be xy. And x is -1, and in this case, 1, 2, 3, 4, 5, 6, 7, -8. So -1, -8. Now, since it's a minimum, it would have a minimum, or the minimum y value, which would be -8. All right, so on to these examples here, just about the characteristics of a quadratic function. So here the vertex, so we look for the highest or lowest point of the parabola. So in this case, it is right here, which is -1, 2, 3, and then -1, 2, 3, -3, -4. So that is my vertex there. Now, is it a minimum or a maximum point? Well, it's a minimum because it's the lowest point. And if I wanted the minimum value, so if I asked for the minimum value, we could say that y is equal to, right here, at the y value of this, which would be -4. But we are asking if it's a minimum or maximum. It's a minimum point. All right, the equation of the line of symmetry. So the equation of the line of symmetry is that vertical line that's going to pass through the vertex. So right here we can see that it's -1, -2, -3. So x equals -3. And I hope you can see the relationship that the equation of the line of symmetry is always going to be the x value of the vertex, whereas the minimum or maximum value will always be the y value of the vertex. X-intercepts, where does it cross or touch the x-axis? So in this case, we're going to estimate them. So I know it's not exact, but I don't really want to make it any more complicated. So I'm going to say this is -10, even though it's probably like -0.75. And this one appears to be -1, -2, -3, -4, -5, comma 0. All right, for the next one, we have the vertex. In this case, it is the highest point, which is at 1, 2, 3, 4. So 4, comma 0 is the vertex. Since it is the highest point, it's called a maximum. And if I ask you for the maximum value, you would say that y equals the y value here, which is 0. The equation of the line of symmetry, so it's that vertical line that passes through the vertex. In this case, it is x is equal to 4. So once again, the x value of the vertex is the line of symmetry, and the y value is the minimum value of the parabola. Or in this case, maximum value of the parabola. X-intercepts, we only have one. Remember, the definition is where does it cross or touch. So this one touches the x-axis at 4, comma 0. Okay. All right, moving on. So what does the standard form of a quadratic function look like? Well, it's f of x or y equals a. So let's see, we can color code this. So a x squared plus, let's see if we can use different colors, b x plus c. I'll use green for this one. So ax squared plus bx plus c. That is your standard form of a quadratic function. And how do I tell this is a quadratic function? Because the x squared is directly termed, and we see the b and the c. Okay. So now for this one, it says if a is positive, so let's say a is positive, then the graph opens up. Okay. So usually when I think of this, if you're having a good day, you're positive. So your graph opens up, you're smiling. Okay. Here, if a is negative, then your graph opens down. So that's that reflection across the x-axis. So here, if you're having a bad day, you're frowning, right? So that's how I think about those there. Now let's talk about the vertex, okay? So the vertex, and we're gonna kind of go through this. Usually the order I would solve these in. So the first thing I would actually do is the axis of symmetry. So let's go over that first. The axis of symmetry is gonna be, let's see if I can color code this, x equals the opposite of b divided by 2 times a. So hopefully you see the color coding. So x equals the opposite of b over 2a. So the b coming from the term in front of x, and the a coming from the term in front of x squared, or sorry, the coefficient in front of x squared. After I figure out my axis of symmetry, then I go to the vertex. Okay, so for here, we write x comma f of x. Okay, and honestly, let's actually rewrite this. Let me show you where this x actually does come from. Okay, so this x, the first x value, we talked about it earlier, that the x is actually the x value of the axis of symmetry. These are the same x value. And I'm writing f of x here, which really means y, because I have to take this x value, plug it into the function, work it out, and get my corresponding y, which in essence will give me x comma y. Okay, so we take this x value, we plug it into here, into the function, and we get our y value. So it comes out to x comma y. And last, we do the y-intercept, and the y-intercept is a pretty easy formula here. It's just that 0 comma, and it's going to be your c value of your equation, right? So over here, right, this value right here. So if it was 3, it would be 0 comma 3. So this is where the graph crosses or touches the y-axis. Okay, now let's go ahead and work an example problem out here. So, and I'll show you exactly how I do this. Okay, so first we're going to find the vertex. Okay, so what I like to do is label what a, b, and c are. So a is in front of x squared, which there's numbers, so it's 1. B is in front of x, which is positive 2. And c is the constant without a variable, which is negative 3. All right, so for my first one, the vertex. I always said to do the, to do the axis symmetry first. So we're going to say x equals the opposite of b. So in this case, the opposite of 2 is negative 2 over 2 times a, and a is 1. Okay, so we're going to do this one first, just like before. So this is going to be negative 2 divided by 2. So x is equal to negative 1. So remember that x equals is the equation of the axis of symmetry. Just like before, we talked about that the x value is the same thing as the x value in the vertex. So x equals negative 1. So for my here, so we're going to do this second. The x value goes into here, which is negative 1. And to get the corresponding y value, we take negative 1 and we plug it into this function. So negative 1 squared plus 2 times negative 1 minus 3. So negative 1 squared is 1. 2 times negative 1 is minus 2. And then minus 3, which would be negative 4. Because 1 minus 2 is negative 1, minus 3 is negative 4. And then the next thing I said to do was I'm going to do the y-intercept. After this, it really doesn't matter what order you do it in. So the y-intercept, we talked about that being 0, comma, in this case, c. So my c value is negative 3, so 0, comma, negative 3. And last, we have a maximum or minimum point. Well, I don't actually need the graph to know this. If I look at A, it's positive, so I know the graph is going to face up. So if it faces up, this is the lowest point, which is a minimum. And that's what the question's asking for right now. It's asking what's the minimum point, and you could say it's a minimum. But the value, what's the minimum value? It's going to be the y value of the vertex. So we could say that y is equal to negative 4. All right, x-intercepts, I'm going to have to get this from the graph. Now let's kind of talk about this next part here. It says, I can't find the x-intercepts yet because I have to graph it. So what I'm going to do is I'm going to show you this original parabola again from the very beginning and just kind of tell you how this works out. That if you were to take this piece right here and fold it over the line of symmetry or axis of symmetry, it would fold right on top of itself, okay? So pretty much what happens is if I can just find one side of this parabola, then the other side will automatically be found because it's a mirror of itself. Okay, so I could just flip this over and get it like that. So let me show you how this works. So with this table here, I know you can't see it very well, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 spaces, so I'm going to go to the middle, which is 5. 1, 2, 3, 4, 5. So right here, I'm going to put my vertex. So V for vertex, which is negative 1, negative 4. Now as I go down, my values get bigger. And as I go up, they get smaller. And if you want it the opposite way, by all means, go for it. So this is my vertex. This is the middle of my graph. So what I'm going to do is I'm going to find out values for this. Okay, so the first thing I do, I just plug them in. But I already know this 0 value. It's 0, comma, negative 3. So what I could do is just put the negative 3 here. And then I'll do 1 next. All right, I'm going to get a piece of paper. I'm going to show you how to do this next part here. And really, you're just going to see me plugging in numbers. So here's my equation. So next, I'm going to plug in a 1. So 1 squared plus 2 times 1 minus 3. So 1 squared is 1. 2 times 1 is 2 minus 3. So 3 minus 3 is 0. Okay. Now I can plug in a 2. So all I simply do is just erase these values here. I'll erase all these just in case, but not necessary. So we're going to plug in a 2 now. So we have 2 in for x here, 2 in for x here. So 2 squared is 4. 2 times 2 is 4 minus 3. 4 plus 4 is 8. 8 minus 3 is not 0. 8 minus 3 is 5. All right, and let's go for the next one. So this one with a 3. So we have, and I'll just write this one out, 3 squared plus 2 times 3 minus 3. So 3 squared is 9. 2 times 3 is 6. And we get 9 plus 6, which is 15, minus 3, which is 12. And from this point, it does go off, but I just finished. Now I'm going to show you one last thing here with this negative 2 value here. So if I were to do negative 2 squared plus 2 times negative 2 minus 3, so negative 2 squared is 4. 2 times negative 2 is negative 4 minus 3. So 4 minus 4 is 0 minus 3, which is negative 3. So hopefully you see the connection here. Like I told you, the vertex splits it in half. So this was negative 3, this was negative 3. They're the same value. So therefore, if this is 0, then this will be 0. If this is 5, this will be 5. If this is 12, this will be 12. Okay? So let's talk about x-intercepts. It's where they cross or touch the x-axis. So when I'm looking at a table, my x-intercepts appear where y value is 0. So this would be an x-intercept, and this will be an x-intercept. So we have -3, 0, and 1, 0. Okay, and from here we just graph it. So I always start with the vertex, -1, -4, and then 0, -3, and then 0, -3, -1, -4, 1, 0. Sorry, I lost track of that. 2, 5, and 3, 12 is off the wrap. So here, if I draw my axis of symmetry, I can just count my spaces, or this is 1, so this is 1, 1, 2, 1, 2. And I'm also, it's like I'm graphing, this is -3, 0. And then this point goes here, and then we draw the graph the best that we can. And you can see I completely missed that vertex, sorry about that. Now there is a shortcut to graphing this, and I will show you how to do that in class, but for right now, just make sure you can plug in values like that. All right, last thing we'll talk about is how to actually convert this to, it's not in the notes, but how to go from standard form to vertex form. So if you recall from your notes, I gave you a transformation equation that looked like this. Okay, so I'm just going to talk about this really briefly. So y equals, let's talk about a. The a value is already given. The a value here is 1, so I'm not going to put it. X minus. So the x value, the vertex, is actually h. Okay, so this is h. So if I take -1 and plug it in here, it becomes +1 squared. Then this y value here is actually k. So it's plus k, so that's going to be -4. And that's actually how you get the vertex form. Last but not least, we have solution types. So there's 3 types. The first one is called two solutions. And the reason why is because it crosses the x-axis twice. So we have 2 solutions right there. This one right here is called a no solution. And the reason it's no solution because it does not cross or touch the x-axis. You'll find out later on this has a special name. And last, this one crosses once. This is what we call one solution because it crosses and touches, or it touches the x-axis at one point. Okay. So like this would be x, 0, x, 0. This would have no solution, and this would be x, 0. In case you're curious.